So, hello. In this session for the Fusion CAM, we would like to try and tackle the problem with the piece that you have planned for machining. So, let's start for the beginning. Last session, we were looking at three-axis machining. We had a certain part and we did elementary three-axis machining functions. We programmed them in CAM. So today we are trying to attack the multi-axis features for CAM programming. As you are planning to use the UMC 500 Haas vertical milling center with a 5-axis capability, if I'm not mistaken. And let's see how we can program it in that sense. What we have to keep in mind is that with our educational license, we have only limited possibilities for the multi-axis functionality, which some of the functionality would be accessible via the machining extension in Fusion. But let's see what we can do. So first thing, we would need to bring in our model. So let's do it. File, open from my computer, and you have to look for it where you saved it. So this should be it in my case. So here we have the part. An important thing to mention in Fusion is that when you bring in neutral format, CAD model in neutral format, as it was a step in this instance, Fusion starts in what is called a direct editing mode, meaning in one sense that you have access to some different tools, but in my opinion, most importantly, you see there is no timeline. In my opinion, it is always good to turn on the timeline. You do that by clicking right mouse button on the main component, and from the menu you open capture design history, and there we have our timeline active now. So as a second thing we would like to do in this design environment would be to bring in the stock, but before we do that, let's first inspect a little bit what we are going to do, at least what we are trying to do here today. I think we are trying to machine this boss feature here, this cylindrical boss feature, and that flat surface over there. And also we will need to pay attention to this groove we have over there. And also we would like to see if we can manage with hole drilling. Yes, this is our plan for today. The next thing in this particular instance, as we have a modeled stock, we should bring in the modeled stock as well. Upload button over there. Select files. I will take this file and I shall upload it. Let's see, I will put it in a more reasonable location. That's good. Select and upload. So it should be seen in this directory of mine. It is also good idea to remember the name. I see I already have it, so from here I'm going to delete it and search for the upload unscaled, right mouse button and insert into current design. So there we have it. There is our casted model as a stock for this project. You have a chance to move it around if needed. In this particular case, it seems to be well positioned, so there is no need to no need to move it around, I assume. And I click OK. So there I have my cat. Both of the models are here. In Fusion Sense, it is a good idea right now to recognize that we have one body, our part to be machined here is as a body, and our stock is as a component. So what I would do, I would take this body again with the right mouse button, and I would create a component from it. So now you see I could also name it to be part. So, and what is going on right now is that actually the part is moving around. It's free to move. You see, I'm moving with my mouse. As I did that, you see there is a special UI appearing, the position menu. And if I did it unintentionally, I should always take the revert position so it goes back to its original location. And this is how I want them to stay. To do that, we would take from the assemble menu rigid group, for example, and I would put those two together like this. Because the first component in Fusion by default is anchored anyway. You see there is a small anchor icon appearing on this component. So now if I try to move my part, you see it's fixed, it's not moving. This is the way I would like to handle this business right now. Okay, truth to be told, I'm not totally familiar with the situation that you have. So I'm going to make some assumptions while programming it. I'm going to assume that we are somehow able to fixture it in the machine. You have some kind of either vice jaws or something you can hold on to it, and not going to pay much attention to that. I'm going to assume that somehow we are able to hold it roughly from this area in the machine. So let's see what we can do in programming wise. We go to manufacture, and we will start with a new setup for milling. New setup, setup menu, new setup. First thing I'm going to do would be to define my stock as from solid, and from that solid would be the this model. This will represent our stock. And also it is quite important to define that our model to be machined would be this part over there. So, and from here on, I can start setting up my work coordinate system. Again, I would like to emphasize that I'm not totally familiar with the physical situation in your machine tool, what kind of holding possibilities there are. But as said, I assume that we can hold on to the stock from this area by some means. And we are going to machine that one over there. Okay. So to set up the work coordinate system, let's see what we can do. To me, right now, most probably I would like to set it on stock somewhere over here. Let's try to do that. So I take this orientation, and I would like to set up the work coordinate system by using the Z and X references. For C reference, why don't we use that face over there? So you see my C was turned in that orientation, being perpendicular or normal to that surface. And for the X reference, I'm going to use this edge. And you see my coordinate axes Z and X are aligned as they should be. And now it's the matter of defining the location of the origin for our work coordinate system, WCS. So origin, let's try to use the model stock box point. Right now, I don't have any points there I could use. Let's see this box point feature, and it doesn't give me suitable point because of the irregular shape of the part. Let's see if something changes if I go and use the select point option, which I could put there, but in reality that would give me some difficulties in how to actually establish it in the machine, especially with the y-axis, because you see there is some kind of radius over there. So perhaps it would be easier to actually locate it in this point on the machine. And for the third and last time, I'm not familiar with the physical setup. I'm doing it remotely. So this is what I would do right now, having such a piece on the machine. So for time being, let it stay over there and we select OK. So this is our setup. You see, we have established our work coordinate system. We have all the geometry here. And now we should tackle machining. Anyway, this boss over here, quite frankly, this is a simple 2D operation which we could do in this setup easily. So we could use our 2D menu where we could, in principle, we could take, for instance, 2D pocket to machine it out. Let's try to do it with a 2D pocket, okay? As with all the toolpath, first you need to select the tool. I'm going to take something from my already established library. So let's use the filter. Let's filter for the flat end mills. I have here a specialized aluminium roughing end mill with a 16 millimeter diameter. And let's see what we can do. I would use select here. And for my geometry, let's try to select this edge. And from the preview, we could also already see it's not that good, but anyway, let's do it. So you see what is going on here is that the program is referencing to the whole stock. So it wants to machine away the whole stock, which is most probably not the best option in our case. Because in strategy that I have right now, I would simply mill through this part. I could try to see what is the thickness of this part here by using the quick measure. So it is 13 millimeters of aluminium. It is no brainer. We could easily go through here, but our 2D pocket is right now it's doing something else. So let's see if we can adjust it a little bit. The first thing we would need to think about would be the stock contour option. So you see this yellow one, this is kind of representative of the boundary box of our overall stock model. I would like to try and put in this edge for the stock and see what is going on right now. Right now, to me, it's looking much better. It's looking much better. You see, it's doing only one pass. And with this one pass, it would rough out this shape. What, to my knowledge, should do the thing. Yes, but we should consider that we are, while doing it, we are cutting through this material. We should be, let's see, let's simulate this toolpath. What I'm talking right now is that we should also consider now the cutting length of our tool, because you see the distance from this highest edge. Let's use the measure tool in Fusion, inspect menu and measure, and let's measure the height difference between those two edges. We see it is 35 millimeters. It is 35 millimeters. And if I now check my tool, I'm not sure what is the cutting length of the tool. So we go to cutter. We see that the flute length is 42 millimeters. So principally it would be okay, but I wouldn't consider it as the safest option. We might consider doing it in different height levels. Let's see whether we can program it or not to do it in different height levels. The 2D pocket option, yes, edit. We have our geometry, we have our stock. We can go to heights and see where does the machining will take place. So our bottom height, if we start from below, our bottom height is our contour. This is fine. And then we see we have our top height, which is in this case would be our stock contour. But what I have in mind right now in my strategy, I'm not worrying about this part over here. I'm considering that with milling, this will just fall off. It is definitely not the best strategy, or the yes, the very recommended way to do it, but today we will do it. But for the top height, I will use the selection option, and I will tell that this surface will be my top height. This surface will be my top height. There is, if I look it from this direction, it is okay. And we can go to passes tab, and you see there is the multiple depths option. This 24 millimeters, which is automatically populated for me, this comes from the definition of my tool. I have taken care in my tool definition. Why don't I show it? So I go back to the tool, and you see if I edit the tool and I look at the cutting data, you see while I defined it in my tool library, I have used this value here, 24 millimeters, which comes directly from the tool manufacturer's catalog. Yes. Why don't we have a look on this as well as while we are here? So I'm going to use the browser and see if I have it in memory. You see, I happen to have it in memory. This is the tool page, this particular tool, and here I have the geometry. And from here, from this info sheet of the tool, these values have been inserted. You see, length of cut is 42 millimeters over there. And these values we have put in here. Okay. So go back to the edit and passes. We have turned on multiple depths, and I think it is fine right now. What I won't use this instance. Let's see. What we stock to leave, I will take it off, and instead we will use the finish pass option. So it will also rough it and use to the finishing pass as well. So finishing pass type, there you can choose between in computer and in control. If this is a tolerance feature, let's assume it is a tolerance feature, we shall use the in control option, so we can essentially tune it from the control. Exactly, and finishing overlap option is also a good thing to put on. It means that the finishing pass will not start and end from the same location. So let's see if it does it work. So it seems to be working. It is doing it on two different levels. These entering moves are these green lines. These are what our lead-ins, and you see, as we have chosen the in control compensation type, it is doing somewhat weird moves over here. If we like, we could try to adjust it from the linking tab of the toolpath. There you have these lead-in, sweep angle, and linear distances, etc. I would like to take away the the vertical radius. I will set it to 0. It's still calculating. Let's put the sweep angle to 0. Anyway, it is fine. What I'm looking at is the shape of these green lines here. So at this point we just take it, but we see we have some kind of warning sign. Would cause a collision. You see, something was not so good. Okay, instead of this, let's try to machine it in a different way. I will take my pocket toolpath, 2D pocket toolpath, and in passes tab, I would take away the finish pass and reuse the stock to leave, and we'll leave there 0.5 on the radial side. Radial stock 0.5. It definitely changed the type of the machining. You see there is some kind of helical ramping going on. This I take from the red lines. Okay, let's simulate it and let's see what will happen here. If I simulate it, let's start the simulation. So it is cutting through the stock material, so this part will fall off in reality, and it is actually, you see, it is going down in this fashion. Okay, we see what we have to change here. So if I now start to think about it, perhaps it is even better idea to face it at the beginning. So we would clear off this part coming from this casted stock of ours. Let's try to use let's use the same tool. So what I'm going to do is right mouse click on the toolpath and take create derived operation 2D milling and facing. The tool is there. The geometry is also there. I will try, let's see what it does now. So it looks actually good, at least to me right now. So I will put this. Now I'm just reordering the toolpath. You see, I took it, hold down the left mouse button, and I just dragged the toolpath. So now this is our face toolpath. The heights are there. Let's see what it's planning to do with the simulation, our facing toolpath. I run it so it starts to face off this part. Most probably we would like to change the depth, but it might not matter actually in reality as we are doing the aluminium. So you see at this point this part would fall off and we are only left with this part over there. I think it's fine. Let's continue with our 2D pocket. And let's see if our 2D pocket had a rest machining possibility. We would try to utilize it. The rest machining possibility. Let's put there the 16 and let's leave it as it is, take away the multiple depth, and let's see what will happen with the 2D pocket. It's not generating. So something is off with our logic right now. Remove the rest machining option and leave with this, and this looks much better actually. This looks much better. Let's see what kind of this we are leaving stock. Let's simulate the whole setup by choosing the setup and simulating the whole setup, and let's just run it. Running it. So there is our facing going on. With this as said, this part would fall off. This part would fall off, and this is what we are left with. You see, we would need to take care of the we would need to finish the diameter. So I would try to yet another time. I'm trying to put on the finishing passes in control and take this option, and let's see. We still have a warning and it's not working. So take away this finishing pass from here, and we try another option with a 2D pocket toolpath. Yet again, we use the derived operation and we take 2D contour and we just run it. It is working. So now let's try to run it with some other kind of compensation type, not in control. Okay, in control, this is what we wanted. So it's working. Let's simulate the whole thing. Start it and go directly to the end. And I think we are fine with this boss. I think we are fine. There is some blue appearing. I try to change the accuracy over there. It is not changing, but I think this is the graphics playing with us. I would like to think that this boss is now machined to its correct diameter. And yet again, we must consider that this part will fall off during machining. This is the strategy that we are taking right now. Should we feel that this is dangerous, I mean, the falling of this leftover stock is dangerous, then we should attend to this. We should find some other means of machining, slowly getting rid of it. It is easily doable with this, even with the facing toolpath. Yes. So right now I take it, and the next thing we would like to pay attention to would be this groove over here. So let's estimate the width of the groove. Taking these two surfaces with a control, I see that the width of the groove is 1.1 millimeter. And we can, in principle, in this setup, we can machine it with a this screwing tool. So let's try to do it. We would use the 2D contour again. This time, instead of selecting it from the menu, I will just duplicate the last one. This is the last one. This is what we are going to change now. Edit. Obviously, we need to change the tool. And let's see what do we have in library for slot milling tools in whole library. Not many of them. What we have to do, you see, there is diameter, and there is the somewhere we have to find what is the thickness of the tool. You see, we have something what is 1 mil. We have a diameter 8 millimeter slot mill with a height of 1 millimeter. So let's try to use this tool. I'm selecting this tool. I'm selecting this. Right now, I take the bottom inner edge of the groove, and I'm just going to, okay, let's clean it, because you see we had the values from the previous toolpath were there, so I'm cleaning it. Again, if we want to attach accuracy, we will use the in control compensation, and let's run it, and let's see if we have a toolpath. You see we have a toolpath, but it is actually not correct, because we must consider that we had a tool that is 1 millimeter, but this particular groove width was 1.1 millimeter. So in reality, it shouldn't machine it in the correct way. Let's check it. Let's double check it with the simulation. I run the simulation. You see there is even a warning given. So let's run to this point. It is telling us that there is a collision, rapid move into stock, which is understandable, because the program is thinking that we still have some stock left there. Shouldn't be a problem. Actually, in reality. But also our groove is not complete. There is the 0.1 millimeter difference there. Different ways we can attend this problem. I think the easiest, most probably, in my opinion, in our case, would be just to duplicate the contour toolpath and to just offset it to 0.1. You see what I mean is that I will duplicate the last toolpath that is machining our groove. I will take this toolpath, edit, and edit the height. If I give this bottom height reference, if I give it a positive offset of 0.1, then this second pass should take care of the whole groove for me. Let's double check it with a simulate option, and let's run it until the end. And if I now check this surface, you see I should have my complete groove machined with these two contour tool passes. To me, right now, this seems to be the most logical way to go. Obviously, there are different other possibilities to program it, but let's take it. And I'm not going to worry about this warning here, because quite clearly there is some mismatch between the understanding of the toolpath and in our real situation, where we have actually cut off. The program is not able to take into account that this part has already fallen. We have free access to this part of the of our piece for machining. Let's leave it as it is for time being. Uh, I'm now noticing a small chamfer on top of here. So why don't we try to do it? It seems to be not a 45-degree chamfer. We could try to evaluate it with a measure tool. Nothing happened. We would need to, let's see if I use those two H's. I see the size of it, but I have still no, we don't have we don't have the angle. What I will try to do, I will try to use the inspect menu and the section analysis tool. If I look it from this side, I take this analysis and I will try to inspect it now with, but unfortunately it is not able to recognize the edges. Another workaround in this instance would be to go back to design menu and actually generate a sketch. I will put in the origin, take my sketch, go to this plane, and on this plane I would like to intersect this body of ours. And from here, if I now hide the body, I am able to establish the but yet again I was wrong. It is a 45-degree angle. It seems to be it is 45 degrees, so all is good. But anyway, it was worth checking it. So put back my model and go back to manufacture. Go back to manufacture and let's try to tackle the chamfer here. Let's see what we can do with the chamfer. Let's see what we can do with the chamfer. I'm going to hide this toolpath and also the analysis, and we will run the 2D chamfer toolpath from here. Let's have some tool. Let's see if I have anything in my special catalog. Usually I define them as spot drills. I have this chamfer mill, 10 millimeters. This is defined here. Actually, in reality, recently I've been using this tool, and let's select this tool. It has all its cutting parameters attached to the tool profile, material profile, and now there is while machining these chamfers, you must pay attention whether we are trying to machine a model chamfer or non-model chamfer. Right now we have a model chamfer. What I will do, I will use the lower edge of this and I am going to OK it. Nothing happened. Nothing happened. So we took our geometry. Was it the upper one? And we must check the passage. Chamfer width is 0. It's 0. Yes. So now you see we have a toolpath, and let's now check it on the simulation if we manage to get it right. So I'm going to simulate this one toolpath only. Let's put on the points. Let's put the tool over there somewhere, and let's try to look on it on the side. You see the side of our tools, side of our tool is well aligned with our chamfer, and we have reason to believe that it is going to machine it. So I'm double checking it again with a simulation, taking off toolpath, putting back stock. and running it and then ending it, and you see that at least on this simulated part we have quite good chamfer over here. So that should be that. Okay, and now finally, actually now, just now we are coming to this multi-axis stuff, because what we would like to do, we would like to drill this hole. We would like to drill that hole, and obviously we can't do it. We can't use our original work coordinate system for drilling that hole. Let's see how we can attend this problem. Um, while at it, I'm going to little bit tune our setup, and something we didn't do last time. Let's define a machine in our setup. I'm going to Fusion library. I'm going to search for milling machine from Haas, and I will see if I have the machine here. If I have the Haas UMC 500 somewhere here, something should be here. You see, I have some UMCs already. UMC 750. Don't see the UMC 500 here. But I'm quite sure that okay, there is 500, my bad. UMC 500 is there. Let's try to use this machine with its configuration, and let's see what happens. Truth to be told, this is the first time I'm doing it. Download model, and let's see where it takes us now. Obviously, it takes some time, so it wants to put this model somewhere. I'm choosing a location and saving it to that location, and it should be inserted. Okay, it asks me to save this file. I'm going to save this link file with Taltech 5th of Tech 2024. There I have it, and I will give another attempt for bringing in the machine. My machines, it should be here. It is here under my machines. And let's see, now we have some success. I'm just accepting it with this, and let's see what happened to our chamfer. Okay, it is telling that the spindle speed, it now comes directly from my machine configuration. I could try to edit the machine, not from here, but actually from our setup menu, and this is where maximum feed rate, general, let's see where we have our additional settings. Somewhere we should have the this is kinematics capabilities. Okay, but actually in reality it doesn't matter. It just means that this machine would run on its highest available RPM rate. Okay, we have the machine, and let's try to do the drilling. Essentially, now when we try to do this multi-axis stuff, you see all this multi-axis menu, for instance. In my case, it's grayed out. It's not available. It should be that you might have some access to it, some limited time access to it, when it is the first time you're using the educational license, which is not the case in my, it's not the case with me. So let's try to do the drilling. We go and choose the only available option of drill. First, we should actually measure the hole. What is the diameter of the hole? It's 5 millimeters. So for drilling, I'm going to take a tool from my library. Just use general 5 millimeter drill from the tool library. Put enter. You see I have something in Fusion library. I take this one. We accept it. It's cool. Now that this is where the magic now happens with multi-axis stuff. In this case, we are doing multi-axis indexing. So first I select the face. You see it's not possible because I haven't done the multi-axis. So I turn on the tool orientation, and what I would need to do would need to put let's try to use it with a setup coordinate system. It's not working. I would need to define my z with this. You see there is our new temporary work coordinate system, and the z is right. Somehow we have to establish now x as well. Let's see if I can use right now the modeling coordinate system. So I try to see if this is applicable from here. So the corrections are good to me. I mean, not the corrections, directions. And let's see. It is now I take the whole and double check my coordinate system. So this coordinate system is still, you see, related to the point of the original one, but what has happened that the axis they have moved for this particular operation. It seems to be fine. I'm just taking it without any other justification. What we would need to do, you see, the drilling is definitely not through. So let's adjust the drilling operation a bit, taking the drilling operation, editing it, and going a little bit with the heights. I'm going to change it. First apply the tip compensation. You see it's somewhat better, but I always like to add some kind of breakthrough depth as well. You see it only accepts positive values. So this is looking from this side, and it should drill the hole. The cycle with aluminium, not paying much attention to that, just simple drilling in and going out. The RPMs and cutting speeds, I'm also not paying attention right now. Something you would need to do when you are actually drilling it with your actual tool. Looks good. Looks good. Anyway, there might be the question also with doing this hole. For this hole, you would need to have some kind of special tool and another machining operation. I'm not totally sure by heart. Is it broaching in English? Could be. You could try to do it with a simple drilling operation, honestly. If you have the tool, you can try to do it with that, because you see, if I take my drilling operation, if I edit it, and if I go to this cycle, I see I have there these different cycles available. And what I would do, I would look at the reaming or boring operation, what they would offer me. Sorry, at this point I actually haven't used them, but could be something that might help me with this strangely shaped hole. So, but anyway, in our case, we have done this stop. We have drilled the hole. What I would like to see now is what would happen with our simulation. So let's try to simulate it with the machine on. Okay, sorry. Right now I took the wrong one. Okay, it doesn't matter. We can run it as this. You see, it is taking care of the business in this direction. And now it's also took that. It actually looks okay to me. So one more time. You see, this is our milling. And then yes, seems to be doing the work. So now let's try to model it with, not model it, but let's try to simulate it with the machine. Again, something I haven't done before, simulate with the machine. Let's see what will happen. Let's see what will happen. You see, now we should have the model of our machine. Stuff looks much more complicated. This is why I don't like the machine on the here. We don't have the work holding equipment. One should take care of having it on the bed, but everything else is good. You see, this is what I intended to be the original setup in the machine. Excellent. And let's run the. We have. You see, we have several. Okay, now this is the. There you see, there is this thing that the machine thinks that we still have this part on, but let's not worry about it. Let's not worry about it at all. I will run the simulation. So now it's taking care of this. It is, you see, it's giving us these stops when saying, okay, and now what happened? Now we should have had the turn. You see, it turned, and it went and did the hole. So essentially, it seems to be working. Essentially, it seems to be working. At least from my perspective. Yet again, I don't have the machine. I have no idea about the work holding equipment, etc. So I take it. Um, um, okay. Let's see what we can do with NC program. It has automatically taken the machine. It has established a post processor, has next generation control. Let's take it. Let's see what will happen. Here, nothing much. We should tune, and operations, we shall take everything. Let's set the program number, documents. Let's open it and let's post it, and let's see if we have if we get something. Right now seems to be okay. Let's scroll down to drilling. Let's see what we have here. Do we have these rotations? You see, we have a rotation around the B axis, we have a rotation around the C. Great. It should be working. Let's check those. There is no rotations due to our setup. So that would actually conclude this short session of ours for today. And let's just quickly go through it again. So what we did, essentially, machining this part over here, this let's call it vertical boss, and the groove. This is actually done in a very similar 2D fashion, due to our original setup, where I was assuming that we can somehow fixture attach this stock of hours in this way in our particular machine tool. This way, yes, this is something in reality it is really simple to change. So these operations until here, just plain simple 2D action, so to say. What we have to, one more time, what we have to consider is that in my strategy, this part over here, this will fall off. At the end of the day, you also need to take care of this part over there, which now I understand that we cannot do it with the assumption I made that we can hold it from here. It will give us some difficulties. So in reality, something else should be done so that we could get rid of this. Again, I don't know what are the real circumstances. That's why I'm not touching this part. These toolpaths will take care of the part, and then the multi-axis fixture, multi-axis indexing, when it comes to play, is only for this drilling. And you see what we did, we just kind of rotated our work coordinate system for that particular operation. We didn't change the location of it. It stayed the same point, but it changed temporarily the axis. And at least on the simulation and also CNC NC code wise, it is working in theory, but you would need to check that in real life practice. At least this is the starting point I would like to give to you, and you could carry on. So I'm saving this file, and would you be interested in having it? I'm ready to share it with you. Okay, so thank you for now.